Navigation lesson. This lesson discusses the general performance-based navigation concept, defines area navigation, defines required navigation performance, and discusses performance monitoring and alerting. Performance-based navigation, or PBN, is a concept developed around the use of area navigation, or RNAV, systems for flight operations. It recognizes and utilizes emerging technologies and improved aircraft navigation capabilities. PBN provides a modern basis for airspace and obstacle clearance design, replacing conventional sensor-based navigation. This includes updated design for oceanic remote, en route, terminal, and approach phases of flight. Conventional sensor-based navigation relies on aircraft reception of signals from ground-based radio navigation aids, such as NDB, VOR, localizer, or DME. In sensor-based navigation, the ground-based signals are used directly to navigate to and from navigation aids. Sensor-based navigation has several drawbacks, including airspace and obstacle clearance design criteria are variable and depend on the characteristics of each ground-based nav aid type. Navigation system error increases as the aircraft increases its distance from the nav aid. And routes and approach tracks are restricted to straight-line designs and are constrained by large obstacle clearance allowances and the physical sighting of the navigation aid or aids. PBN relies on an area navigation system, which receives position information from a combination of signals from satellites, onboard inertial reference systems, and certain ground-based navigation aids. In PBN, ground-based signals are not used for direct navigation purposes. Rather, they provide additional position information. PBN has several advantages over conventional sensor-based navigation, including airspace and obstacle clearance design criteria are made more consistent and independent of different or changing navigation technologies. Navigation system error is linear and does not change according to distance from a waypoint. Routes and approach tracks can include turning designs and are less constrained by obstacles due to smaller clearance allowances. Navigation route design no longer needs to consider nav aid sighting issues. And finally, the navigation function is performed by highly accurate and sophisticated onboard equipment, allowing a reduction in cockpit workload and an increase in safety. The PBN concept relies on the use of an RNAV system. Two core inputs are required for the application of PBN: the NavAid infrastructure and the NavAid specification. Applying these components in the context of routes and instrument procedures results in a third component: the navigation application. This topic will discuss the role of each of these components in the concept of PBN. The concept of NavAid infrastructure refers to ground or space-based navigation aids. Ground-based navigation aids include NDB, VOR, and DME. Space-based nav aids include GNSS elements. As mentioned previously, PBN uses the two types of nav aids together for position fixing and navigation. Navigation specifications describe the requirements placed on the area navigation system for operation along a particular route, procedure, or airspace. The system requirements include the performance required of the area navigation system in terms of accuracy, integrity, continuity, and functionality, the functions available in the area navigation system so as to achieve the required performance, the navigation sensors integrated into the area navigation system that may be used to achieve the required performance, and flight crew and other procedures needed to achieve the performance mentioned of each navigation specification. The concept of continuity is a major factor in determining whether a navigation installation can meet the requirements of PBN. It involves the reversionary, non-RNAV means of navigation available, and what degree of redundancy is required to ensure adequate continuity of functions. Each navigation specification requires a level of continuity to be demonstrated by the navigation equipment prior to operation in RNAV/RNP airspace routes. Additionally, the RNAV system must have a level of integrity required by the given navigation specification in which the aircraft is operating. Integrity characterizes the navigation system's ability to provide a timely warning when it fails to meet its stated accuracy. The safety of the operation is also contingent upon the accuracy, resolution, and integrity of the data being used. The processes applied during data origination will ensure the accuracy of the data. A navigation specification that includes a requirement for onboard navigation performance monitoring and alerting is referred to as an RNP, or Required Navigation Performance Specification. A navigation specification that does not include a requirement for onboard navigation performance monitoring and alerting is referred to as an RNAV, or Area Navigation Specification. For any particular PBN operation, it is possible that a sequence of RNAV and RNP applications is used. Be aware that compliance with one specification does not automatically imply compliance with another. More importantly, being compliant with a more stringent specification does not automatically imply compliance with a less stringent specification. Each RNAV and RNP specification will be discussed in detail later in the lesson. The navigation application refers to utilizing the appropriate infrastructure and the specification required for the operation. Examples of how the navigation specification and the NavAid infrastructure may be used together in a navigation application include RNAV or RNP SIDS and STARS, RNAV or RNP ATS routes, and RNP approach procedures. RNAV systems range from single sensor-based systems to systems with multiple types of navigation sensors. The RNAV system typically integrates information from sensors such as air data, inertial reference, radio navigation, and satellite navigation, together with inputs from internal databases as well as crew-entered information. Both RNAV and RNP specifications include requirements for certain navigation functionalities. At a basic level, these functionalities include continuous indication of aircraft position relative to track to be displayed to the pilot flying on a navigation display situated in his or her primary field of view, display of distance and bearing to the active to waypoint, display of ground speed or time to the active to waypoint, navigation data storage function, and appropriate failure indication of the RNAV system, including the sensors. An RNP system is an RNAV system whose functionalities support onboard performance monitoring and alerting. The performance monitoring and alerting capabilities may be provided in different forms depending on the system being used, including display and indication of both the required and estimated navigation system performance, monitoring of the system performance and alerting of the crew when RNP requirements are not met, and cross-track deviation displays scaled to RNP in conjunction with separate monitoring and alerting for navigation integrity. The airworthiness approval process assures that each item of the required area navigation equipment installed is of a type and design appropriate to the operation. Additionally, operators need to ensure the required installations will function properly under foreseeable operating conditions. An RNP or RNAV specification is a statement of the navigation performance or accuracy required to conduct specific flight procedures or for operations in specific airspace regions. In oceanic remote, en route, and terminal phases of flight, PBN is limited to operations with lateral performance requirements and time constraints. During the approach phase of flight, PBN accommodates both linear and vertical operations. For lateral and longitudinal navigation accuracy, an RNP or RNAV value is expressed in nautical miles of desired position or track. Actual navigation performance, or ANP, is a measure by the FMC of its position accuracy. ANP is expressed in nautical miles as a radius around the FMC position. The FMC estimates that there is a 95% certainty of the aircraft's actual position being within the ANP distance of the FMC position. A smaller ANP indicates a more accurate aircraft position relative to FMC position. A larger ANP indicates a possibly less accurate aircraft position relative to FMC position. ANP is normally a low value, but may increase if degradation of satellite or ground-based signals occurs, or if equipment failures occur on board. The area navigation system must be sufficiently accurate to ensure that the ANP is maintained within the RNP or RNAV distance of the desired route or procedure 95% of the time. To account for the small percentage of time when the aircraft position may be outside the RNP distance, a containment limit distance of 2 times the RNP value is expressed for airspace separation and obstacle clearance. The RNAV system must be sufficiently accurate to ensure that the aircraft's actual position is maintained within the containment limit distance of the FMC calculated position 99.999% of the time. The inability to achieve the required lateral navigation accuracy may be due to navigation errors related to aircraft tracking and positioning. The three main errors in the context of onboard performance monitoring and alerting are Path Definition Error, or PDE, Flight Technical Error, or FTE, or Navigation System Error, or NSE. PDE is the difference between the defined path and the desired path. In most cases, PDE is considered negligible, since the named routes and procedures retrieved from the navigation database are consistent, repeatable paths. A consistent, repeatable path cannot be defined for a turn that allows for a flyby turn at a waypoint, a flyover waypoint, or occurs when the aircraft reaches a target altitude. For these, a variability of route will be expected. Onboard performance monitoring and alerting of PDE are managed by gross reasonableness checks of navigation data. FTE refers to the pilot or autopilot's ability to follow the defined path or track. FTE can be monitored by the autopilot or with crew procedures, for example, with a moving map display. NSE is defined as the difference between the aircraft's estimated position and actual position. Total system error, or TSE, is the total of the errors combined mathematically, not simply added together. The TSE must remain equal to or less than the required accuracy for 95% of the total flight time. Abnormal and contingency procedures are to be used in case of loss of the PBN capability. These procedures will depend on the RNAV system installed and the specification of operation. PBN is based on the ability to assure reliable, repeatable, and predictable flight paths for improved capacity and efficiency. This requires not only the functions traditionally provided by the RNAV system, but may also require specific functions to improve procedures and airspace and air traffic operations. Some of the specific capabilities we will discuss include fixed radius paths, RNAV or RNP holding, and lateral offsets. The fixed radius path, or FRP, can be one of two types: radius to fix, or RF, leg type, or fixed radius turn, or FRT. The RF leg should be used when there is a requirement for a specific curved path radius in a terminal or approach procedure. The RF leg is defined by a radius, arc length, and fix. RNP systems supporting this type of turn provide the same ability to conform to the track-keeping accuracy in the turn as in the straight line. The FRT is intended to be used with en route procedures. Due to how the procedure data is defined, the RNP system creates the fixed radius turn. There are two possible radii associated with this type of turn: 22.5 nautical miles for high altitudes above flight level 195, and 15 nautical miles for low altitudes. This enables improvement in airspace usage through closely spaced parallel routes. During a flyby turn, the RNAV system uses the aircraft's speed, bank angle, wind, and track angle change to calculate a flight path to smoothly transition from one segment to the next. Considering wind changes and differing aircraft performance, the turn initiation point and turn area can vary. Flyby turns are an integral component of an RNAV flight path. In the concept of holding, the RNAV system defines the inbound course to the holding waypoint, as well as the turn direction, the leg distance or time, and the ability to exit the hold. RNP further improves the hold with a flyby entry into the hold, minimizing the needed protected airspace on the non-holding side, consistent with the RNP limits. RNAV systems may provide the capability of a lateral offset flight path, either for the length of the route or temporarily. When an offset is activated in the RNAV system, the departure from the route will typically be at an angle of 45 degrees or less. Generally, offsets are in increments of 1 nautical mile up to 20 nautical miles, as specified by the pilots. Upon cancellation, the system again uses a 45-degree or less angle to return to the defined route. Most RNAV systems discontinue the offset in the terminal area or at the beginning of an approach, at an RNAV hold, or during course changes of 90 degrees or greater. Path terminators are a set of specific codes that define a type of termination from a path. Path terminators are assigned to all SIDS, STARS, and approach procedures and include, but aren't limited to, IF, or initial fix, TF, or track to fix, CF, course to fix, DF, direct to fix, FA, fix to an altitude, and CA, course to an altitude. We will now discuss the details, requirements, and procedures for each RNAV and RNP specification. Some requirements are common to all specifications and are included in this section. Commercial operators must have a training program addressing operational practices, normal and contingency procedures, and specific items related to the specification. In order for operators to get approval for RNAV/RNP operations, they must prove their aircraft are properly equipped with the appropriate navigation system. Additionally, some specifications define the instrument display requirements, such as being visible to the pilot in their primary field of view and the navigation map having lateral deviation functionality. This lesson will not discuss all the specifics required, rather the crew operations required for each specification. Operators and pilots intending to conduct operations in RNAV or RNP airspace need to use the appropriate ICAO flight plan designation. For RNAV, this means filing with the appropriate flight plan suffix indicating approval for operation on the route. For RNP operation, the letter R should be placed in Block 10 of the ICAO flight plan to indicate the pilot has reviewed the planned route of flight and determined the RNP requirements and the aircraft and operator approval. The accuracy capability should be placed in the remarks section. Pilots must review aircraft maintenance logs to ensure proper operation of equipment required for the RNAV or RNP accuracy. If an MEL is utilized, ensure the inoperative equipment allows for RNAV or RNP dispatch. Additionally, pilots need to ensure onboard navigation data is current and includes the appropriate procedures required of the operation. The database must be valid for the current Aeronautical Information Regulation and Control Cycle, unless otherwise specified in Operations Documents or AMC. For any operation utilizing GNSS, operators are required to ensure appropriate RAIM is available for the operation. Navigation equipment failure contingencies appropriate to the operations being conducted will have been approved and trained in the pilot's training program. Should any failure occur, the pilot should revert to this training as appropriate. Additionally, the pilot must notify ATC of any loss of RNP RNAV capability and their intentions. All pilots are expected to maintain route centerlines during all RNAV operations, unless authorized by ATC or in an emergency. For normal operations, cross-track error deviation is limited to plus or minus half the required accuracy of the route. For example, 0.5 nautical mile for RNAV1, 0.5 nautical mile for RNP1, 1 nautical mile for RNAV2, 2 nautical miles for RNP4. Brief deviations from this are allowable during and immediately after procedure or route turns. The deviation must not exceed 1 times the navigation accuracy, 1.0 nautical miles for RNAV1, 2.0 nautical miles for RNAV2, and so on. RNP values may be changed automatically by the FMC to certain default values, or may be set manually by the crew when required by procedures. Typical RNP settings for flight operations are Oceanic airspace, RNP 10 or 4. Continental en route, RNP 2. Terminal airspace, RNP 1. Approach and departure, RNP 1. RNP approaches, RNP .1 to .3. RNAV-10 has been designated for operations in oceanic and remote areas. Though the designation of the airworthiness and operational approval, as well as airspace and route designation, is RNP-10, it will be referred to as RNAV-10. This is to keep consistency with the differentiation of RNP requiring monitoring and alerting, and RNAV not having this requirement. The lateral TSE for RNAV-10 must be within plus or minus 10 nautical miles for at least 95% of the total flight time. The along track error must also be within plus or minus 10 nautical miles for at least 95% of the total flight time. Additionally, RNAV-10 supports 50 nautical mile lateral and 50 nautical mile longitudinal distance-based separation minima. RNAV-10 requires that the aircraft operating in oceanic and remote areas be equipped with at least 2 independent and serviceable long-range navigation systems, or LRNSs, comprising an INS, an IRS-FMS, or a GNSS. For aircraft utilizing dual INS or dual IRU systems, RNAV-10 operations have a time limit of 6.2 hours of flight time. The timing starts when the systems are placed in navigation mode or at the last point at which the systems are updated. Aircraft equipped with a single INS or IRU and GNSS do not have these time limitations. Prior to entering oceanic airspace, the position of the aircraft must be checked as accurately as possible by using external nav aids. This may require DME and/or VOR checks to determine navigation system errors through displayed in actual positions. Cross-checking procedures must be used in flight to identify navigation errors in sufficient time to prevent aircraft deviation from cleared routes. Any deterioration or failure of the navigation equipment below that required, or deviation due to a contingency procedure, must be reported to ATC. RNAV 5 operations are typically conducted en route and on arrivals. During operations in RNAV 5 airspace or routes, the lateral TSE must be within 5 nautical miles for at least 95% of the total flight time. RNAV 5 operations are based on the use of RNAV equipment that utilize inputs from one or more of the following to determine the aircraft position along with a means to establish and follow the desired path. VOR DME, DME, INS or IRS, and GNSS. RNAV 5 requires no regulation to carry a navigation database, and therefore is subject to the limitations associated with manual insertion of waypoint coordinates. Additionally, since the specification does not require the aircraft to be installed with dual RNAV systems, an alternate navigation source must be operable in the event of loss of RNAV capability. Generally, RNAV 2 is used en route, while RNAV 1 is used for terminal phases of flight, including arrivals and departures. During RNAV 1 operations, the lateral TSE must be within plus or minus 1 nautical mile for at least 95% of the total flight time. Additionally, the along track error must be within plus or minus 1 nautical mile for at least 95% of the time. Similarly, during RNAV 2 operations, the lateral and along track error must be within plus or minus 2 nautical miles for at least 95% of the time. Pilots must not fly an RNAV SID or STAR unless it is retrievable by name from the onboard database. The pilot should confirm the routing conforms to that of the charted route. Once loaded by name, the SID or STAR may be subsequently modified by the entry or deletion of specific waypoints in response to ATC clearances. The manual entry or creation of new waypoints by latitude and longitude values is not permitted. Additionally, pilots may not change any RNAV SID or STAR database waypoint from a flyover to a flyby and vice versa. Although not recommended, routes can be built using named fixes waypoints from the database, as long as all fixes along the published route to be flown are inserted. The route may be subsequently modified by the insertion and deletion of named waypoints in response to ATC clearances. As with SIDs and STARs, the creation of waypoints by manual entry of latitude and longitude values is prohibited. To use an RNAV SID, The pilot must be able to use RNAV to follow lateral flight guidance no later than 153 meters or 500 feet above airport elevation, though published RNAV guidance on a given route may begin higher. For aircraft using GNSS, the signal must be acquired before the takeoff roll commences. Pilots must use an authorized method to achieve an appropriate level of performance for RNAV-1, which includes lateral deviation indicator, navigation map display, flight director, and/or autopilot. Route modifications in the terminal area may take the form of radar headings and direct-to clearances, which must be complied with. Insertion of waypoints loaded by name from the database may be required and is acceptable. To reiterate, manual entry or modification of the route using waypoints not in the database is not permitted. We will now discuss RNP specification details. RNP-4 is designed for operations in oceanic and remote airspace, therefore has no requirement for ground-based nav aids. During RNP-4 operations, the lateral TSE must be within plus or minus 4 nautical miles for at least 95% of the flight time. The along-track TSE must also be within plus or minus 4 nautical miles for at least 95% of the flight time. The flight technical error should not exceed 2.0 nautical miles to satisfy the 95% accuracy requirement. GNSS is the primary means of navigation for RNP-4, either as a standalone navigation system or as part of a multi-sensor system. For RNP-4 oceanic or remote airspace operations, at least 2 serviceable independent LRNSs must be installed and operable. Much like RNP-4, RNP-2 is used in the en route and oceanic or remote phases of flight. Also like RNP-4, GNSS is the primary means of navigation for RNP-2, either as a standalone navigation system or as part of a multi-sensor system. For RNP-2 oceanic or remote airspace operations, at least 2 serviceable independent LRNSs must be installed and operable. During operations in airspace or on routes designated as RNP-2, the lateral TSE must be within plus or minus 2 nautical miles for at least 95% of the total flight time. The along-track error must also be within plus or minus 2 nautical miles for at least 95% of the total flight time. To satisfy the 95% accuracy requirement, the flight technical error should not exceed 1 nautical mile. RNP-1 is designed for arrival and departure procedures and is very similar to RNAV-1. The main difference is the requirement in RNP-1 for onboard performance monitoring and alerting. Additionally, RNP-1 primarily utilizes GNSS and may include RF legs. Pilots must not fly an RNP SID or STAR unless it is retrievable by name from the onboard database. Once loaded by name, the SID or STAR may be subsequently modified by the entry or deletion of specific waypoints in response to ATC clearances. The manual entry or creation of new waypoints by latitude and longitude values is prohibited. The lateral TSE of RNP-1 operations must be within plus or minus 1 nautical mile for at least 95% of the total flight time. Additionally, the along-track error must be within plus or minus 1 nautical mile for at least 95% of the time. To satisfy the accuracy requirement, the FTE should not exceed 0.5 nautical mile for autopilot or flight director, or 0.8 nautical mile for manual control. RNP 0.3 is used in all phases of flight except oceanic remote and final approach. The lateral TSE of RNP 0.3 operations must be within plus or minus 0.3 nautical mile for at least 95% of the total flight time. Additionally, the along-track error must be within plus or minus 0.3 nautical mile for at least 95% of the time. This specification is for use by helicopters. The RNP approach allows the pilot to fly an approach utilizing GNSS as the primary navigation system for lateral guidance. The approach can be non-precision or precision depending on equipment utilized. In flying the approach without vertical guidance, it is flown to an LNAV MDA as stated on the published instrument approach procedure. The RNP approach may only be utilized if it is loaded by procedure name from the onboard navigation database. The pilots must ensure the route conforms to the charted procedure prior to the initial approach fix. The missed approach segment may be based on conventional nav aids, VOR, DME, etc., or GNSS-based. During the pre-flight, the pilot should ensure sufficient means are available to land at the destination or alternate should there be a loss of RNP approach airborne capability. In flying the RNP approach, during operations on the initial and intermediate segments and for an RNAV missed approach, the lateral TSE must be within plus or minus 1 nautical mile for at least 95% of the total flight time. Additionally, the along-track error must also be within plus or minus 1 nautical mile for at least 95% of the total flight time. During operations on the final approach segment, the lateral TSE must be within plus or minus 0.3 nautical mile for at least 95% of the total flight time. The along-track error must also be within plus or minus 0.3 nautical mile for at least 95% of the total flight time. The 95% FTE should not exceed 0.5 nautical mile on the initial and intermediate segments and an RNAV missed approach. The 95% FTE should not exceed 0.15 nautical mile on the final approach segment. Manual entry of coordinates into the RNAV system by the crew for operation within the terminal area is prohibited. Direct to clearances may be accepted to the IF, provided that the resulting track change at the IF does not exceed 45 degrees. A direct to clearance to the FAF is not acceptable. The lateral definition of the flight path between the FAF and the missed approach point must not be revised by the crew under any circumstances. The aircraft must be established on the final approach course no later than the FAF before starting the descent. The crew must check the approach mode annunciator or equivalent is properly indicating approach mode integrity within 2 nautical miles before the FAF, unless the system clearly indicates to the crew that the approach mode is activated. The procedure must be discontinued if the navigation display is flagged invalid, in case of loss of integrity alerting function, if integrity alerting function is enunciated not available prior to passing the FAF, or if FTE is excessive. Vertical guidance on a precision RNP approach can come from either barometric or baro VNav, or localizer performance with vertical guidance or LPV, which is a satellite-based augmentation system. A baro VNav type of approach uses GNSS aided by the barometric system. The vertical guidance supplied by the baro VNav system must be certified for this purpose. This 3D approach requires the current altimeter setting of the landing airport. Remote altimeter settings are prohibited. Additionally, flight crews should be familiar with the pronounced effect of non-standard temperature on baro VNav operations. Temperature limitations published on RNP approach procedures need to be complied with, unless the avionics system has temperature compensation capabilities. When baro VNav is used for guidance during the final approach segment, deviations above and below path must not exceed plus 30 meters and minus 15 meters, or plus 100 feet and minus 50 feet. Pilots must execute a missed approach if the lateral deviation exceeds 1 time the RNP, or the vertical deviation exceeds 22 meters or 75 feet, unless the pilot has the visual references required to continue the approach. LPV is a 3D operation utilizing the GNSS for both lateral and vertical guidance. Pilots fly to a decision altitude along an angular guidance, which increases in sensitivity as the aircraft gets closer to the runway. An RNP approach to LPV minima requires use of a final approach segment, or FAS, data block. The FAS data block contains the lateral and vertical parameters that define the final approach to be flown. The air traffic service provider submits all LPV-specific data required by a data house for the coding of the procedure in a navigation database. RNP approaches that require authorization are labeled RNP-AR approaches. These types of approaches may only be conducted by flight crews meeting special training requirements in aircraft meeting specified performance and functional requirements. For RNP-AR approach procedures, curved routes between the FAP and the runway are possible. All aircraft must have a cross-track navigation error no greater than the applicable accuracy value of 0.1 nautical mile to 0.3 nautical mile for 95% of the flight time. The along-track positioning error is also held to this standard. Missed approach RNP values can be less than 1. Minima DA/DH can be as low as 250 feet. Advanced RNP, or ARNP, enables more accurate and predictable flight paths for enhanced safety and efficiency. It is used to operate in the en route, terminal, approach, and departure phases of flight. ARNP incorporates the navigation specifications RNAV5, RNAV2, RNAV1, RNP2, RNP1, and RNP approach, and requires RNP capability. ARNP may be associated with other functional elements. An RNP navigation specification requires onboard performance monitoring and alerting. This is accomplished on the B737NG by displays of RNP and ANP values to the flight crew, lateral and vertical navigation performance scales on the PFDs, nav performance scale alerting, and FMC alert messages. Current lateral RNP and ANP values are displayed in numerical form on the FMC legs page. Current lateral and vertical RNP/ANP values are displayed in numerical form on the FMC progress page. Current lateral and vertical RNP/ANP values are displayed in numerical form on the nav display or ND. Lateral and vertical nav performance scales are located on each PFD to provide additional displays of RNP and ANP values. The symbology on both the lateral and vertical scales are identical. The hollow center white index represents the aircraft position. The solid white end scale symbols represent the current RNP value. The ANP bars originate from the outer scale and expand inwards. The length of the ANP bars indicate the ANP value relative to the RNP scale. The magenta pointer symbol indicates the required lateral track or vertical path location relative to the aircraft position. If flight technical error occurs, the magenta pointer will move away from the center aircraft position index. Acceptable nav accuracy is maintained as long as the magenta pointer does not reach the inside end of the ANP bar. If flight technical error is so large that the magenta triangle moves into the ANP bar, acceptable nav accuracy is no longer being maintained. After 10 seconds, the magenta pointer will flash and the ANP bars will turn amber. If the flight technical error exceeds the RNP value, the magenta pointer turns hollow and parks outside of the RNP end scale marks. If ANP increases due to degradation of nav input signals or onboard equipment failures, the ANP bars may merge in the center of the nav performance scale. Merged ANP bars will also turn amber. The FMC provides various alerts to the flight crew for navigation performance monitoring. If ANP grows to the RNP value or greater, the FMC alerting message, Unable Nav Performance RNP, will appear in the CDU scratchpad. If a manually entered RNP value is greater than the FMC default RNP value, the alert message Verify RNP appears. When the navigation performance scales are enabled and the manually entered vertical RNP is greater than the default vertical RNP value, or the manually entered vertical RNP is greater than the current vertical ANP value, the alert message Verify Vertical RNP Value appears. Onboard performance and alerting in the Airbus is different from that in the Boeing aircraft. Displays on the A320 include required and estimated navigation performance, level of accuracy, lateral and vertical navigation performance scales on the PFDs, and FMC alert messages. current lateral RNP is displayed in the required field of the progress page. The displayed RNP is, in decreasing order of priority, the flight crew manually entered value, the nav database procedure value, or the system's default value. The display also shows the estimated position uncertainty, or EPU, what Boeing calls ANP. Accuracy is displayed between the two as high if the EPU does not exceed the RNP, or low if the EPU exceeds the RNP. When in IRS GPS mode, the GPS primary status combines two different criteria: the accuracy criterion already described, whether high or low, and an integrity criterion, which is the capability to detect a failure and provide appropriate warning of it. When both criteria are met, GPS primary displays in green on the progress page and temporarily on the ND. If both criteria are not met, the GPS primary is removed from the progress page and alerts are displayed. It is possible to clear the scratchpad message on the MCDU, but not on the ND. When RNP is 0.3 nautical miles or less, a lateral deviation scale is presented on the PFD, and an improvised cross-track error is presented on the ND. The deviation scale on the PFD allows the pilots to monitor lateral deviation during low RNP procedures, SIDS, STARS, or NPAs, where 1 dot equals 0.1 nautical miles. The index will be either green or magenta depending on standard. If the LS push button is pressed, lateral deviation displays in amber and no deviation is displayed. The LAT deviation scale is not displayed if a hold, a PI leg, an FM leg, or a DF leg is active, when the lateral deviation information provides a misleading indication of the direction to be followed to come onto the active flight plan, or in the done phase. When on an RNP approach and the approach push button is pressed on the FCU, the vertical deviation scale is displayed on the PFD. This should be done prior to the vertical interception point, or VIP, and on the vertical flight plan. At the VIP, a blue arrow on the ND indicates that final approach engagement conditions are met. The ND displays the cross-track with 2 digits after the dot when the aircraft is below the transition altitude and cross-track is greater than or equal to 0.02 and less than or equal to 0.29. The FMC provides various alerts to the flight crew for navigation performance monitoring. When a flight crew manually inputs an RNP value that is higher than the published RNP, One of the following appears in the scratch pad. Procedure RNP is, or area RNP is. This notifies the crew they should verify the RNP value entered in the required field of the progress page and clear or modify it as necessary. Accuracy switching from high to low triggers the amber nav accuracy downgrade on the MCDU and ND. If accuracy becomes low, GPS primary lost displays on both the MCDU and ND. The white nav accuracy upgrade message appears on both when the accuracy becomes high again. Refer to your company's operating manuals for proper procedures on RNAV and RNP operations.